What if lightning only struck the same place? This question comes from Jeremy, who asks, what if lightning only ever struck in one place? At first glance, this sounds like a boring world. After all, one lonely patch of ground somewhere on Earth would take every single lightning strike. Everywhere else, cities, forests, mountains, would be safe from thunderstorms. No power lines fried, no trees split in half, no unlucky golfers suddenly becoming very crispy. But when you start thinking through what would actually happen, you realize that this single lightning spot would be both the safest and most dangerous place on Earth. Let's imagine how it would play out. First, we need to decide where the spot is. Nature doesn't like ambiguity, so let's assume the laws of physics pick a single square meter of Earth's surface, permanently and forever. Every lightning bolt in the world, whether from a storm in Florida, a monsoon in India, or a volcano in Iceland, will ignore the sky above and instead curve through space to that 1 square meter. We'll call it the spot. In the first few days, the spot is just weird. Farmers nearby notice their fields don't get lightning anymore. Cities far away realize thunderstorms are quieter, missing that bone-shaking crack. Insurance companies breathe a sigh of relief, at least until they learn where the spot actually is. The first lightning bolts hit it, then the second, then thousands more. Normally, Earth gets about 1.4 billion lightning strikes per year. That's roughly 40 every second. Imagine all of that compressed into a single, unlucky square meter. Within minutes, the ground turns to glass. Within hours, it's a crater. Within days, it's a molten pit that refuses to cool because every new bolt pours in more energy. The energy isn't small. A typical lightning strike carries about 1 billion joules, the energy of 250 grams of TNT. One strike isn't catastrophic. 40 strikes per second, all in the same place, is like setting off a steady stream of explosions. The spot doesn't just glow, it rages. By the end of the first week, scientists are losing their minds. News crews set up cameras at a safe distance. Reporters try to narrate while deafening thunder drowns them out. The spot has become a natural wonder, Earth's own endless fireworks show. Tourists flock to see it. Though none stay close for long, every strike launches shockwaves that rattle bones. And then come the problems. First, the atmosphere. Lightning doesn't just hit the ground, it ionizes the air, creating shockwaves of heat and ozone. Normally, the sky spreads this out across the planet. But now, one tiny column of air is being cooked relentlessly. Oxygen molecules split apart, recombine into ozone, then split again. The column above the spot becomes an unnatural chemical soup. Birds avoid it. Planes reroute. Satellites looking down notice a strange glowing scar on Earth's surface. Second, there's the heat. Each strike superheats the air to 30,000 Kelvin, hotter than the surface of the sun. Usually, this heat diffuses quickly into the atmosphere. Here, it stacks. The spot becomes a vertical furnace, punching hot plumes upward. A permanent thundercloud forms. Not because it's raining, but because the air is being forced to rise continuously, condensing moisture in giant spiraling towers. From space, Earth seems to have grown a single thunderous pimple. Third, there's geology, the crust below. The spot doesn't appreciate being electrocuted millions of times. Rock melts, minerals vaporize. Cavities expand underground as the heat boils away groundwater. Eventually, the land collapses. The spot becomes a deepening pit, maybe a kilometer across, glowing like a forge, lightning spearing into it without mercy. Humans naturally try to intervene. Someone builds a giant lightning rod hoping to catch the bolts higher up. It works for a few minutes until the rod vaporizes into plasma and sprays molten metal everywhere. Others try underground bunkers, lightning-powered generators, even launching rockets into the spot to see what happens. Answer: nothing useful. The rockets melt before they get anywhere interesting. Politicians argue over ownership. If the spot lands in the ocean, maybe on a lonely patch of the Pacific, then congratulations. You now have the world's deadliest boiling pot. Within hours, seawater would vaporize faster than it can flow back in, creating endless steam explosions. Surrounding ecosystems collapse, fish flee. The spot becomes a roaring white geyser visible from orbit. Shipping routes are permanently changed to avoid it. Climate scientists panic as the plume begins altering wind patterns. But what if the spot lands on land? If it appears in a desert, fine, the desert just gets a permanent glowing pit. If it lands in a major city, say downtown Tokyo, then Tokyo is gone, permanently, evacuated, reduced to rubble. You cannot live next to 40 lightning strikes a second. The thunder alone would rupture eardrums. The electromagnetic pulses would fry electronics for kilometers around. Hospitals, airports, data centers, all useless. The city would be abandoned overnight. Let's fast forward a decade. By now, the spot has reshaped Earth. The constant lightning has dug itself into the mantle, creating a semi-permanent magma lake. The atmosphere above is permanently altered, a churning superstorm that can be seen from the moon. Humanity has built an exclusion zone around the spot, guarded like Chernobyl, but infinitely louder. And yet, scientists love it. They study it obsessively, pointing instruments at it, writing papers about the physics of infinite lightning. Cultures adapt too. Some call it a punishment from the gods. Others worship it as a divine beacon. Pilgrimages form, though tourists rarely last long before they retreat from the deafening thunder. Conspiracy theorists insist it's a government weapon. TikTok is full of videos titled, "I went to the spot, and here's what happened." But the biggest impact is on global energy. Every lightning bolt carries power, and all that power goes to one place. Theoretically, if we could tap it, we'd have limitless electricity. Engineers build colossal power plants around the spot, with towers and superconductors designed to channel the bolts. The first prototypes fail spectacularly, melting, exploding, catching fire. But eventually, some energy is captured. Humanity enters a new age, lightning-powered civilization. Of course, there's always a catch. The spot keeps growing, eating its way into the crust. What happens when it breaks through into the mantle? The answer isn't good. The molten pit expands. The planet develops a new volcano. Only this one is fed not by tectonics, but by the sky itself. A volcano that never stops erupting, driven by 40 lightning bolts a second. So what if lightning only struck in one place? Well, insurance companies would celebrate at first. Cities everywhere would stop worrying about storms. People would sleep through summer nights without a single thunderclap. Farmers would keep their barns, power lines would survive, but one unlucky square meter of Earth would become the loudest, brightest, hottest, deadliest, and most fascinating place in history. And if you ever visit it in person, remember the lesson. When the optimist says at least it's only in one spot, and the pessimist says that spot is doomed forever, the physicist doesn't answer. They're too busy wearing earplugs and running very, very far away.